my presentation is called Killing Bugs, One Vulnerability Report at a Time. And it's the story about behind what's the latest with the FreeSWITCH advisories that we released this week. So a bit of an introduction. I'm Sandro Gauci. Hello. And I'm the author of SIP-Vicious OSS, the open source SIP-Vicious. It's a security testing tool set for SIP. I've been around information security since over 20 years. And the last 13 years, what I've been doing is related to offensive security and leading enable security. We focus on voice over IP and WebRTC security, that is doing penetration testing, security audits, developing security tools, and doing consultancy and training in the area of WebRTC and voice over IP security. So everything that I talk about here is not just my work, but it's a team effort. So when I use I, it means we. So I should also introduce a bit SIP-Vicious Pro quickly, because what we're doing is we're developing a new security tool set, the SIP-Vicious Pro. It's totally different from the open source version. So it's a complete rewrite, and it focuses on real-time communications security in general, not just SIP. But I mentioned this because much of the vulnerabilities that we found in FreeSWITCH had actually to do with SIP-Vicious Pro. So I'm going to mention that a lot. This presentation is about the security advisories that we released this week. These vulnerabilities that we described in the advisories were fixed in the latest release. So go get it if you didn't already. It's version 1.10.7. And we will be talking about how these vulnerabilities were discovered, reported, and then fixed. So these were the titles. These are the titles of the advisories. The first one is a SIP digest leak vulnerability. Then there was a denial of service through SIP flooding, 2 authentication-related vulnerabilities, and finally another denial of service through which affects the SRTP handling in FreeSWITCH. Now, since 2 of them are quite similar, I thought I would be telling 4 different stories originally, and I even came up with fancy titles for them. You know, I got a bit creative here. But as I started working on my presentation, I realized that everything is so connected that I cannot talk about the process of finding or discovering one bug without mentioning another. So what we have is one longer story to talk about. But we start from the beginning. We start from a position of ignorance because until quite recently, we had no real practical experience with FreeSWITCH. It's always been on the radar, of course, but we never actually sat down and configured one. So, and that's probably because none of our main clients back then seemed to use it in the products or services that we were testing. But we did come across it, of course. We did set things up a little bit every now and then. For example, this is a bash script that we wrote in 2018, and it's running our fuzzer continuously. And when we did run this against FreeSWITCH, this is what happened. So FreeSWITCH was killed. And then a year later, we were testing our DDoS simulator, and we tested it against various different products, including FreeSWITCH. And here again, FreeSWITCH was killed. There's a huge time in between each episode. And then there was Camellia World and the dangerous demo there where we participated, and we were demonstrating our DDoS simulator against a target. We did not know what the target is going to be. Someone else set it up for us remotely. And it happened to be a Fusion PBX, which is, of course, based on FreeSWITCH. And I have to say, the target only lasted maybe a few seconds. We don't really know. But we did win the award of most entertaining demo. So that was pretty cool. And then a few months later, of course, we were still confused about what happened during this live session. So we set up Fusion PBX on a VPS and started testing our tools. And then this happened. And yeah, we couldn't even SSH in, so I had to use the console. And after recovering, after a restart, we ran some other tools. For example, we ran the zip method enumeration tool. And we saw the following. So we saw something like this. And what's interesting is these lines here. Now, the zip method enumeration tool is part of ZipVicious Pro. And what it does is it sends different zip messages, different zip message types, and tells you how the target responds. And if any of those responses are 200 or 202, that means that no authentication is required, which tends to be a problem for servers on the internet, of course. This is not something you would expect on the internet. So, of course, these were obvious red flags retrospectively, but we were full of doubt and denial. We were not very sure of ourselves here, and we had a lot of questions. Were we doing anything wrong in our tests? What was the real impact of these issues? Because sometimes you find something which appears to be a security problem, but might not be in many cases a problem. Were these only things that you see in a lab environment only, or were there real world scenarios? And since what happened with the dangerous demos was on Fusion PBX, was this specific to Fusion PBX, or was it more general and affected FreeSWITCH? And finally, who do we contact? Which is a very good question. Back in 2017, quite a while ago, we had contacted someone associated with the FreeSWITCH community and eventually submitted a report even, but nothing came out of it. So that was a bit discouraging, but then we got busy again. So more time passed, and that was 2020. And we decided to learn how to configure FreeSWITCH a little bit. And by June, we had a working setup and a demo showing two things in the default FreeSWITCH configuration. We were showing that we could spoof zip messages, zip messages, and then we could also use subscribe to monitor call events. So I have a demo here showing what we saw in this case in our lab environment. So we have ZipVicious on one side and Zyper, the soft phone, on another side, and we're just using ZipVicious to send a message without requiring any authentication, and you can see that Zyper receives the message. Now that's well and good. And there's no authentication happening, like I mentioned. Now we're going to edit the zip message and set our own from address and set our own a different body. And you can see that the message comes in from the pancake monster selling you their pancakes, spamming your client. And this client, of course, the Zyper is connected, is registered with FreeSWITCH. So that's the whole point. Now, around the same time, we noticed that a potential client of ours was also vulnerable to, we saw the same behavior that we're demonstrating here, because it turned out they were using FreeSWITCH. So we were asking ourselves, how widespread is this problem? And to find that out, one could use something like Shodan, which has already scanned the internet multiple times. And yeah, when you look up FreeSWITCH on Shodan, of course, various things come up, various different IPs, and one could then run very simple tests to find out if this is a problem or not. Not saying that we did that, but one could do that. And what one would realize is that this is a widespread problem. So more time passed, we got busy, and then FreeSWITCH 1.10.6 was released late in March 2021. So we remembered that FreeSWITCH did need some love and attention, and we had the question of, had they fixed any of the issues that we had seen but not yet reported? So we started looking at the code and configuration changes. And there was one particular night where I couldn't sleep, 7 or 8 April, and I did what any other hacker would do, I suppose, review the latest commits of FreeSWITCH to see what the changes were in the latest release. And what we noticed was that the flag auth subscriptions was added to the default configuration. Now this is good because it starts authenticating subscribe messages, but it was not good enough because any upgrades are not going to be affected because they're going to keep using the old configuration. So I was bored, and it was, midnight or something like that. So I said, let's try and test the digest leak tool. It's not ideal if you want to sleep, but that's what I did. And what this tool does is it starts using SIP invite, and when the other party hangs up with a bye message, it asks the other party to authenticate by sending a 407 SIP response with a challenge. But nothing happened. So I did that, and what was interesting was this line, though, in the FreeSWITCH logs. Cannot locate any authentication credentials to complete an authentication request. And so it didn't find these credentials, but what if it did find matching credentials? So we tracked the code and realized that you need to set up a gateway. So to do that, I uncommented the default gateway configuration and ran the tool again. And this time, I could see the following. And what's interesting is, of course, the response, which includes the challenge response, which is based on the password. Now, next day, I did manage to get to sleep, but the next day, we had two advisories to write up, start working on the drafts for those. It was the digest leak vulnerability, and there was also the anonymous or unauthenticated message vulnerability. Now, I still had some curiosity left from the night before because I hadn't tested one particular tool that I should have tested, which was the SIP flooding tool. And I tested it in the probably afternoon, I suppose, on the FreeSWITCH TCP port handling SIP. And this happened. So FreeSWITCH was killed by the system with an out-of-memory error. So suddenly we ended up with 4 different vulnerabilities for FreeSWITCH. Started working on the reports for each of them, especially the reproduction steps, to make sure that we can consistently reproduce these issues. But who should we contact? So recently there was OpenSIPit, and we had just participated in this event. And we had met some of the lead developers for FreeSWITCH there. So we asked the organizer, Maxim, or one of the organizers, who redirected us to David Duffett, who ended up redirecting us to Chris Rienzo, who was the right man for the job. So we contacted Chris, and he told us that there was no actually security reporting process in place. This was similar to what we had seen when we reported something, a vulnerability to Cotern, the Cotern open source project. And they had successfully used the GitHub Security Advisory feature. So we quite liked that, and we suggested the same. So FreeSWITCH started using that. And then we could send our first report. We didn't send the first two reports that we discovered, but rather we sent the digest leak vulnerability because it was the easiest for us to polish, and the FreeSWITCH developers could easily reproduce the issue by using tools that they know, such as SIP-P. So the next reports took a bit longer to send. Why did it take so long? Well, let's take a look at how a security report looks like. So first you have the description, and it needs to answer the question, what's the big deal? It needs to get the developer interested to accurately describe what we're doing and also the result of what we're doing. And in this case, since we wanted to make it very, very clear that the memory was not being freed, we graphed the memory and included all this information in our description report. And then there's the impact section, and it tries to answer what's the worst case scenario? How bad could it be? And also, how easy is it to pull it off, to pull this attack off? Does it require authentication, for example? That would affect the impact section. Now, in the case of denial of service, it's pretty clear that the impact is critical, especially in real-time communications. You can't have real-time communications when the system is down. But with something like the subscribe authentication issue, it was not clear how bad the problem is, and it wasn't as bad as we originally anticipated. So it took us quite a while to write the few lines that we wrote in the impact section in this particular advisory. And then there's the how to reproduce the issue section. Now, this is, I think, the most important part of each advisory. The steps need to be really, really clear. The scripts that we include to reproduce the issue need to work properly. We have to do quality assurance on these things. Because when we do fail to do a proper job out of this, we get something like, we cannot reproduce this issue from the developers. Or this issue is not as bad, that's what they might tell us, because they might not be seeing exactly the same results that we are seeing. They might see some effect, but not exactly the same thing. So, and then there's the solutions and recommendations section, and in this we try to guide the developers towards what we think are good solutions. There are many solutions that might fix a problem or appear to fix a security problem, but not all of them work so well, and some of them actually introduce new problems, whether it be new security problems or usability problems, and so on and so forth. And then once we made sure that all 4 security advisories were sent, we could confirm that we can present at ClueCon on 2 main conditions. So we made some conditions in this case. We wanted to make sure that the FreeSWITCH developers are okay with us talking about these vulnerabilities. And it was very important that the security fixes were made available before we could talk about the security vulnerabilities, so that people in the audience can, and everywhere else, can fix the security issues before we start publishing stuff. So no pressure there. And actually, these conditions were, of course, accepted, and that's why I'm speaking here. So what's next? Well, some issues are easy to reproduce, others are easy to fix, but not necessarily both at the same time. And what I mean is, for example, the digest leak issue was easy to reproduce, but fixing it, I realized that there were various places which needed fixing. So it wasn't as easy as reproducing the issue. Difficulty number two was that the denial of service issue with the memory consumption. Well, in this case, we needed to have various discussions, and we had a call with the developers to make sure that they could actually see exactly what we were seeing. So we noticed that memory consumption was never getting freed up after the attack, and they did not see this. Now, the reason for this appears to be because we had better tools. We had SWITCH Pro, and they only had the simple scripts that we provided them with in our report. Now, and the solution was communication. Sometimes that's the only thing, the best thing that can work. Now, at some point, the developers started making their fixes available to us, and we tested to make sure that the fixes were correct. Some patches might not address the vulnerabilities that we report. So it's very important that we test these things before the patches make it to production. And in the case of the zip flood fixes, for example, the first patch did not actually fix the issue. So what we did, we created a new video demo showing that we did apply the fixes and we could still kill the server. And this very quickly meant that the next day we had a new patch that actually did work, did protect against the attack. So that worked very well. And then there was this fifth report, right, that in the original advisory list. That came quite later. So we were developing the WebRTC component of SWITCH Pro and adding the TLS SRTP support. And it turned out that FreeSWITCH was the easiest system for us to test against, so that we have something that works to test against. And while testing the SWITCH Pro SRTP code, we started noticing the following error messages. SRTP audio unprotect failed, lots of that, and then ending call due to SRTP error. Now, this was a typical rookie mistake from our part because we were sending incorrectly encrypted SRTP packets. So, of course, this was a bug from our part, but we were thinking also, what if we forced this error on other people's calls? Well, there's only one way to find out. And we did the test. We ran, simulated a call, a normal call with SRTP, and sprayed that call with invalid SRTP packets. And we could see that the victim users got a buy, which ended the call, and the reason was SRTP read error. So what this means is that an attacker could simply spray the FreeSWITCH server with invalid SRTP packets, and the error is then generated, terminating the encrypted calls. Now, since we found this quite late in the whole process, I think in September we reported this to the developers, but luckily it was relatively easy to address. You just needed to ignore the SRTP errors, so that was also fixed. And finally, it's ClueCon time. So yeah, this week the latest FreeSWITCH release was published, and this included the security fixes for these vulnerabilities. And we published our advisories as well. Now, some takeaways. We learned a lot through this. It's been coming a long time. But yeah, the most funny thing that we learned is that our buggy software helps us find bugs in other people's software. So that's pretty cool. But what's important for us is that security testing tools are available. Otherwise, it would have been impossible to find these sort of problems. And it's, of course, very, very important that reports are clear our reports are clear if we are to be taken seriously. Something for the open source developers. So obviously, as an open source developer, it's very important to be able to handle security reports. So having a process in place is great. And what GitHub did with the security advisory feature is actually quite nice. Thank you, Microsoft, I guess. But something that is cool, for example, is the private forks, which allows you to provide security fixes to security researchers without committing that to a public repository until the thing is properly fixed. So, and of course, if you're a FreeSWITCH user, and I suppose a lot of people in the audience are, please do upgrade. I hope this presentation helped you understand if any of these security issues affect your installations and setups. But regardless, I would recommend upgrading because there will be security fixes which were applied in the past, probably, and it's good to keep up to date. So that's it. Thank you very much to the FreeSWITCH developers for working with us. It was great to work with you and inviting us to talk about this. And also to my colleagues, Alfred and Pinaki, for their work in this. And yeah, in the slides, we have some references that you might want to check out. And if you want to get in touch, this is our where you can subscribe to our latest newsletter as well, where we talk about RTC security in general.
Great work, Sandro. Thank you very, very much. And before we even talk about your presentation, I'd like to encourage everybody to give a round of applause for Sandro's and his team's work in highlighting those vulnerabilities and the FreeSWITCH team's work in fixing those vulnerabilities in the latest release. So a big round of applause for that. Top class. Thank you very much, Sandro. Now let's see if we've got any questions from the live audience. I checked online just a minute ago, and there weren't any in the chat that I can see. Fernando says, awesome work, Sandro. So there's a commendation from Fernando in the chat there. Any questions for Sandro from the live audience here? We have a microphone over there that people can use if they'd like to. Otherwise, I guess people have taken Sandro's contact details from that last slide, and so they can get in touch. It doesn't appear that there are any questions, Sandro, and so in order to keep things running on time, I will say thank you very, very much, and we will give a very big ClueCon round of applause to Sandro for his presentation. Thank you very much, Sandro.
Thank you.